Okay, 4.1 is all about radian and degree measure. So we're going to be looking at two different angle measures, kind of like units. Degrees and radians. We know what degrees are. We know all the way around a circle. So from here, let's just say I'm going clockwise, this would be 360 degrees. We know that halfway around is 180 degrees. We're used to this being 90 degrees. And down here would be 270 degrees because it's 90 degrees past your 180. Radians are another way to measure angles. When we are using radians, we're actually going to be using this pi symbol a whole lot. A radian is more like the distance of the turn. So think about all the way around a circle. That'd be your circumference, is equal to 2 times pi times your radius. The circle that we are basing all of this off of is called our unit circle. It's what I was for Halloween, with a radius of 1. So if r equals 1, my circumference is 2 pi, which means that if I start here and go all the way around, by the time I get back over here, I've gone 2 pi. So that would mean if I went halfway around, that would just be pi. If I went a quarter of the way around, so think of that as being half of pi, that's pi over 2. And here I'm going 3/4 of the way around, or 1 and then another half. Alright, so the bottom one was 3 pi over 2. We will do a whole lot more with these throughout the week and through the chapter, but just as a brief introduction to them, that is what you need to know. What we're going to be using for the most part today is this 180 and pi, that those are actually in the same spots, because we're going to try to do some conversions. So converting from degrees to radians. As I just showed you, pi, radians, and 180 degrees are the same thing. So if I multiply by pi radians over 180, that's really like multiplying by 1, which doesn't change anything. So to convert this from degrees to radians, I'm going to multiply by pi radians over 180 degrees. The degrees symbols will cancel. Those units cancel with each other. So I'm left with 120 pi over 180. Now, as always, I want the simplest answer, but also the most exact answer. So you should not be typing in your pi symbol, but 120 over 180 would reduce to 2/3. So I have 2 pi over 3 radians. Go ahead, pause this, and do numbers 2 and 3. I'll put up the answers for you to check in just a second. Alright, go ahead and check your answers. For 2, you should have gotten 4 pi over 5 radians, and for 3, you should have gotten negative pi over 9 radians. If I'm going backwards, so from radians to degrees, I'm going to multiply by 180 degrees over pi radians. Again, 180 degrees over pi radians is like multiplying by 1. To keep straight which one goes on top, since I want to go to degrees, my degrees goes on top. So I'm going to have pi over 5 times 180 degrees over pi radians, and this was radians over here. So the radians cancel. My pi's will also cancel. I now have 180 degrees divided by 5, which is just 36 degrees. Go ahead and do 2. Okay, I got 1,170 degrees. Do not let me mess you up. On 3, I'm going to do 4.8 radians times 180 degrees over pi radians. The radians will cancel. 4.8 times 180 is 864. This is still over pi. So I would go ahead there and type that in, and I get about 275.02 degrees. Coterminal angles. So these are angles that actually land in the same place. So for example, 90 degrees starting here, and I'm always starting on this spot, lands right there in that position. And if you think of that circle from the previous slide, ooh, sorry about that, starting at 0, I land here on 90. That's 90 degrees. I could go the other direction. So if I went from here all the way around this way and wanted to land there, so that's here, and I go around this much, that is 270 degrees. To show that I went clockwise, that is a negative 270 degrees. A third option would be if I wanted to go around multiple times. So maybe I start here, I go all the way, let me go the correct direction, sorry. Start here, go all the way around, and then go 90 more degrees. So if I'm drawing that, start here, go all the way around, and then end up here at that 90. That would be 450 degrees. So that's if I want to like look at the actual picture, how I'm visualizing it. To get these, I started with 90 degrees. I'm going to subtract a full circle. So subtract 360 degrees. That's how I got the negative 270 degrees. Or I could add a full circle. So add 360 degrees. That's where I got the 450 degrees. I could add 5 full circles. So I'd really be adding 1800 degrees, which would give me 1890. So I'd be going around 5 times and then go 90 degrees. That would still be coterminal. We typically just try to go the closest we can for a negative and the closest we can for one more positive. To do it with radians, instead of adding 360, you're going to add 2 pi. So I'm going to do 13 pi over 6. Ugh. If I subtract a circle, so subtract 2 pi, that will give me a coterminal angle. If you're struggling with how to do that, remember you want common denominators. So 13 pi over 6 minus 12 pi over 6 would be 1 pi over 6. So pi over 6 radians would be the same, coterminal to 13 pi over 6 radians. Now this is still a positive answer. I want a positive, so there's that one, check, and a negative answer. So to get my negative answer, I'm going to need to subtract maybe 2 circles. So 13 pi over 6 minus 4 pi, because that'd be like going around twice. So that'd be the same as 13 pi over 6 minus 24 pi over 6, which would be a negative 11 pi over 6 radians. So there's my negative answer. So if I'm in degrees, I'm adding 360, subtracting 360. If I'm in radians, I'm either adding 2 pi or subtracting 2 pi, or for either case, if I need to go further, add 720 or add 4 pi. Just keep adding those circles over and over. Complementary and supplementary angles. We have done this back in like middle school and in high school some more. Complementary angles add to 90 degrees. Supplementary angles add to 180 degrees. Okay, except for that now we do more than just degrees, we also do radians. So 90 degrees in radians, you can either do your conversion, multiply it by pi radians over 180, or think of that circle I showed you at the very beginning, where 90 is the same as pi over 2 radians. And 180 degrees is the same as pi radians. So that's what they add to for complementary and supplementary. So if I wanted to say find the complementary angle to 36 degrees, you're going to do 90 minus 36. Where I'm saying find the complement and supplement for 2 pi radians, we'll do complement first. I'm going to do pi over 2 minus 2 pi over 5. If you need to, convert these so that you have a common denominator, which would be 10. So instead of pi over 2, I'm going to have 5 pi over 2. And this would be 4 pi over 10, which would leave me with pi over 10 radians. So that's my complement. For my supplement, I'm going to do that one over here. So it's adding to 180, or in this case, since I'm in radians, it's adding to pi. So I'm just going to say pi minus 2 pi over 5. Convert to a common denominator if you need to, or just subtract that. I end up with 3 pi over 5 radians for my supplement. The thing to remember, your answer when you're finding the complement and the supplement has to be positive. So if I say find the angle that is complementary to 100 degrees, that'd be negative 10. That does not work. Your supplementary angle, so adding to 180, would be 80 degrees. That one's okay. So for the complementary angle, you would just say does not exist or none. If you guys have any questions, make sure you come in tomorrow and let me know.